In this lesson, we are taking what we saw in the previous module about transformations and moving them forward. In this particular lesson of the new module, we're talking about translations. I believe in the next module you'll see we're talking about reflections and rotations. So the explore activity here is telling us that we can use tracing paper to model translating a triangle. On the screen, I'm going to simulate the activity that your lesson is describing. Your lesson describes doing this on tracing paper, and my hope is that I can kind of duplicate that process as closely as possible. So part A, step A says first draw a triangle, label it ABC, and then draw a line segment XY. So your diagram might look like this. And then it says use tracing paper to draw a copy of the triangle ABC. So I've made a copy of triangle ABC, and it says copy XY so that the point X is on top of point A. So here's my tracing paper triangle, and I'm going to take this segment and bring it over until X is on top of A. So here's A, B, C, and this is also X, Y. And it says labeled point made from Y as A prime. So this point up here, I'm going to also call A prime. And then what you do is in your textbook, it describes doing the same thing here and doing the same thing here. Because I'm using a smartboard instead of using tracing paper, I'm going to show you that in the end, you would have something like this. And so it's asking you, finally, to measure the distances A to A prime, B to B prime, C to C prime, and XY, and then to describe how they all compare to XY. Well, think about how you found the point A prime, and the point B prime, and the point C prime. Here's A to A prime. Here's B to B prime. And C to C prime is kind of off my screen, but hopefully you kind of get the idea that since they were all formed with that XY segment, they are all the same as the length of XY. Here we're talking about some of the vocabulary associated with translations. We use vectors frequently to perform translations, and a vector, as you can see, is a quantity that has direction and magnitude. So magnitude you can think of as a length, and direction naturally is a direction. And when you're looking at this vector V on the screen and you see that it has an initial point, E, that's the starting point, and a terminal point, F, that's kind of where the arrow ends, I would understand if it might be confusing to look at this and see a vector as opposed to a ray. Try to understand that a ray is a part of a line that goes forever in one direction. And that forever means that it has no length. It has no magnitude. A vector, however, that arrow is just indicating a direction. It's not indicating that it goes forever. A a vector, does not go on forever. It has length, which we refer to as its magnitude. So when we're doing a translation along a vector, the segment joining the point and its image will have the same length as the vector, which we noticed in the previous screen. We noticed that A prime, B prime, and C prime were all the same length as our vector. And we didn't talk about it on this screen, but I'd also kind of hoped that you'd notice that, I'll use a different color, that B prime, A prime, and C prime are all parallel. And that's very important. In this example, we're using the vector to draw the image of ABCD after this translation. As I've mentioned in previous videos, notice that this is a part B to example 1, which means that there's an example A in your text. Maybe you want to pause the video here, look over that part A, which is done completely for you, before you look at part B that I'm about to do for you. Okay, so in this translation, in the step-by-step process that they have us starting by drawing a vector from the vertex A that has the same length as vector V and is something to vector V. I would hope that you would realize that it's going to be going in the same direction as vector V. So it has the same length and direction, or is parallel to, I like direction, as vector V. So I might want to make a few observations about vector V. Notice that it's going to the left 3 spaces and up 5. Okay, so when I draw that vector from point A, I want to make sure that I'm following along that line. So I'm going here to A prime. Oops. And notice that from A to A prime, it is the same length as vector V and it is the same direction as vector V. So it says that the terminal point A prime will be, oh hey, we already addressed this. It's 5 units up and 3 units left. And they want us to draw 3 more vectors that are parallel from B, C, and D with terminal points B prime, C prime, and D prime. So we're doing the same thing over and over again from B, C, and D. So 1, 2, 3, 1, 2, 3, 4, 5. There's B prime. And that's my vector. From C and D. Draw segments connecting A prime, B prime, C prime, and D prime to form the image. So I'm just going to connect the dots. Now we're taking that to the next level into the coordinate plane. Notice that we have notation now for how to write a vector, and it looks very much like a coordinate, an x, y. and it's called component form, and it does pretty much what you would think it does. The component form, notice for the ray PQ indicated on the right side of your screen, is 5, 3, because from P to Q, I'm going positive 5 spaces horizontally, and horizontally is X, and positive 3 spaces vertically, and again vertically is Y. So we can use component form of a vector to draw the coordinates for a new image. And you see what the rule would look like if I'm moving something to the right, if I'm moving something to the left, up or down. Notice if I'm moving something to the right or left, I have something going on in my x's, whereas if I'm moving something up or down, I have something going on with my y's. So it gives you two ways to look at a translation. We have dealt with rules before, the coordinate form of a translation. You see that x comma y with an arrow going to x plus a comma y plus b. And that is the same exact thing as saying I'm moving the image along the vector a comma b in component form. It's just two different ways of saying the same thing. And in this example, we're taking that and applying it. So my pre-image coordinates are given to me. I am given a vector in component form. It's -2, 3. So you see in the table that they gave you that we're going to be subtracting something and that we're from the x, and we're going to be adding something to the y. And based on the component form of the vector, I'd hope that you'd notice we're going to be subtracting 2 from the x and adding 3 to the y. And now I'm doing just the same thing that we did back in lesson 1.3, where we just followed the rule in order to identify the new coordinates of our point. Now it's asking us, before we plot it, to make a prediction of what quadrant this figure will be in. So let's start by plotting the original figure, the pre-image. So A is located at 3, 0. B is located at 2, -2. And C at 4, -2. So here's my original figure. And the component form of my vector says to move it to the left 2 spaces and up 3 spaces. So when I take this triangle and move it to the left 2 spaces and up 3, I predict that this image will be in quadrant 1. So let's follow the rule. X minus 2 gives me that this is 1. Y plus 3 means that that's 3. Following the rule for 2, -2, I have 0, 1. And following the rule for 4, -2, 4 minus 2 is 2. -2 plus 3 is 1. And since all of my coordinates are positive, both x's and y's, I know that my answer, my image, will be in quadrant 1. Let's plot it. 1, 3, that's A prime. 0, 1, there's B prime. And C prime is at 2, 1 here. And so when I connect the dots, I find that my prediction was correct. My image is in quadrant 1. Take a moment and work through the your turn below. Here, we're looking at a translation that happened and trying to figure out what happened to it. So in this example, example 3, once again, notice that the example on the screen is part B, which means that there is a part A to go along with it in your text. You may want to pause the video at this time, look over that part A before I do part B on your screen. So you notice once again they are walking us through some portion of it, and what they want us to do is to draw the vector from a vertex of ABC to its image A prime, B prime, C prime. Okay, so I'm going to pick my A's from A to A prime. There's my vector. And it's asking me to determine the components of it. So in order to do that, they said, hey, notice that the horizontal change from the initial point, which is -3, 1, to the point 2, 4, the horizontal change from the initial point -3, 1 to the terminal point 2, 4 is something minus something. It's very important that you take note of the order in which you do things. Since A is my starting point and A prime is my ending point, you want to start with where I ended and figure out what I subtracted from it. So 2 minus -3 is 5. So my horizontal change was a +5. If you had done that backwards, you would have ended up with a -5. So again, make sure that when you're looking at it in this manner, go from your new point minus your old point. Vertical change from the initial point to the terminal point is new y-coordinate minus old y-coordinate, which is 3. So writing this vector in component form would be that this vector is 5, 3. So that gives me the vector by which triangle ABC was translated in order to yield A prime, B prime, C prime.